the guided solutions video for the 1.5 concept quiz on functions. I'm going to be working through all the problems that you encountered on the checkpoint so that you can compare this against the work that you did to hopefully help understand some of the mistakes that you might have made in your first attempt, so that if you'd like to grow from that and make improvements with a reattempt, you can do so. So starting with our first 80 level question, using the input and output sets in the mapping diagram, well, I said below, really it's to the right, draw an example of a relation that is not a function and explain how your diagram reflects this. There are multiple different ways you could have done this. The main thing I would have been looking for something that was not a function is that you have any one of these domain members being paired to multiple range members. So as long as any one of these, like say maybe 0, had a pairing line to 8, but also 12, and then everything else could literally do whatever you want. 4 can go to 40, 5 can also go to 40. That would not be a function because 0 as an input goes to 2 different outputs, and a function can't do that. So as long as you had something in your diagram that represented an output from the domain going to multiple elements of the range, then you would have credit for this 80 level question. The next one, if f of x equals 4x squared minus 3 times x plus 7, what is f of negative 2? Remember that when we see a statement that looks like this, when they give us a value inside the parentheses, that means that is an input number. So we're going to plug it in for the x values to see what the output was. So this function, when evaluated for an input of negative 2, would equal 4 times negative 2 squared minus 3 times negative 2 plus 7. Now, where you do want to be careful next is your order of operations absolutely matters. So in this case, if I am doing negative 2 squared, that needs to be the first thing by order of operations. That is going to be 4 times positive 4. Watch out here, minus 3 times negative 2 is going to become minus negative 6 plus 7. See what I did there? And then 4 times 4 is 16. Minus negative 6 becomes plus 6 plus 7. I'm not going to say it. 16 plus 6 plus 7 is going to give us 22 plus 7, which should simplify to an overall output of 29. And so f for an input of negative 2 gives an output of 29. Okay, and our third 80 level question. In this case, you were given a graph that represents the growth of bacteria in a pond modeled by this exponential function. Which inequality best represents the range of f? So first big thing that you would need to remember in this case is that what domain comes from the x-axis, range comes from the y-axis. So if I'm talking about range, I want to look at my lowest value to my potential highest value. Now, I will say, depending on how you chose to interpret this graph, you might have represented your range in 2 different ways. And as long as your representation made sense, I would accept it under either of the 2 sets of assumptions. The first thing you want to kind of notice is while we don't have a value listed here, you can ballpark that at probably around 1,000 because it's roughly halfway between this tick mark and this tick mark. Up here is looks like it's about roughly halfway between 14,000 and what would be the next tick mark at 16,000. So you could assume this is probably capping out at 15,000. Now, what is not clear in this graph is, does the graph continue or not? Typically, we would expect to see an arrow. We don't, but we would also typically expect that if it ended there, we would see an endpoint, which we don't. So it's not really clear. Does the graph continue or does it not? If you assume the graph continues, then we could just say that the range is 1,000 to infinity. If you wanted to write that with a 2-sided inequality, you could say y values are greater than 1,000, well, greater than or equal to 1,000, going up to infinity. Or you could just simply say that y is greater than or equal to 1,000. Either of those would be acceptable notations to say that the range is everything 1,000 and higher. This would be if you assume the graph continues, right? So if you were under the assumption that the graph continues, this would be an acceptable answer choice. If you assume that the graph stops here, then you would want to bound your range as all values of 1,000 up to 1,500, in which case we could say the values of y are greater than or equal to 1,000, but also less than or equal to 15,000. And that would be an appropriate way to describe the range of the graph if you are assuming it stops here. So as long as you had something that either looked like this with the assumption that it goes on forever, or something like this with the assumption that it stops there, I would accept either of those as valid answer choices since the graph was admittedly a little bit vague. Okay, and now we move on to the 90 level questions. So this is where things started to turn up in temperature, largely because these are now contextual word problems. So we've got more information coming at us and more things we've got to kind of figure out. Here we have Ferdinand Freight Company that charges a flat rate of $200. So there's that showing in the equation, plus 75 cents per pound of weight. To transport freight in the metro area, this cost is represented by the function where W is the weight, so that's our input, and C of W is the cost given the weight. So over here, we're saying cost as a function of weight as the input is found as 200 plus 0.75 times the weight in pounds. Using the function, you're asked to determine a maximum possible freight volume, so that's the thing we don't know, that could be transported by this company under a $2,000 budget. So here's the real crux of the question. What do we do with that 2,000? Is that something that should go in for W as an input, or should it go over here for C of W as an output? And in order to answer that question, you have to think about the relationship between input and output. And that information is lurking here. W is the weight, and cost as a function of weight is the cost given the weight of the freight. So this notation here is telling us that cost is the output based on weight as the input. So we know that W represents the input, C of W represents the output. We're trying to determine a possible freight volume. Now, freight volume is basically the same as weight, right? So we want to determine what W is under a $2,000 budget, which is effectively meaning that we can have a maximum cost of $2,000. So that represents an output value for the function, which means it would go over here on the output side. So what you would need to do for the setup here is replace C of W, output side of the rule, with what we know is our expected cost. We have a budget of $2,000, which that would be determined as a $200 base plus 75 cents for however many pounds of weight we are shipping. Notice that now we have an equation that we can work backwards to solve for W, the thing we want to know. So this goes back to all of our classic rules for solving equations. First step would be to subtract 200 from each side. 2,000 minus 200 should give us 1,800. Those cancel out, and now I have 0.75 times W. And then the last step is to divide out to cancel that multiplication. That cancels out, and so the weight would be 1,800 divided by 0.75. You can throw that in a calculator, and you will get 2,400. So what this means is that the maximum possible freight volume that the company could transport under a $2,000 budget is 2,400 pounds. So that's our final result. This 90 level question there's not really any like number crunching work that we have to do. This is more of a reasoning and thinking question. You are asked to describe an appropriate domain and range to represent the function scenario based on the context. Well, the context is that we are thinking of a relationship of cost. So this is our function, our cost function, as a function of number of months of membership. So that tells us that in this case, the input is number of months. The output is the cost of the membership. So when we think about domain, we're thinking about the input set, right? What are the reasonable values that could be inputs? Well, we know that M represents months of membership. Is it possible for a person to be a member for a negative number of months? No, that's just not logical. It doesn't make any sense. So we know that the domain cannot include negative numbers. Could it include 0? I guess technically you could argue that 0 could be a possible value, though it would seem more in my, like, I think there's an argument to say that really, like, you would have to be a member for at least 1 month, right? And so if you make the assumption that you have to be there for at least 1 month, then your domain would be values of M greater than or equal to 1. Everything that's higher than 1 month or more, is however many months you would pay for a membership at a local gym. Now your output is your cost membership. Well, if 1 is the least number of months that you can attend this gym, 50 plus 30 times 1 would be an output of 80. So that would mean that your lowest output for C of M would end up being at minimum $80, or it could be higher. So we would expect that a reasonable domain for this situation would be M greater than or equal to 1. Oh, excuse me. And C of M being greater than or equal to 80. Now, some of you might have said that there's a limit, right? So for instance, one student I encountered said, okay, well, it's definitely going to be 1 or higher, but they're probably not going to do it for more than 12 months at a time in the contract. And that makes sense. You typically sign a contract for a membership at a gym for a year. So you could assume that the domain is values between 1 and 12. Well, then that would mean that your outputs for the cost could be as low as 80, or they could be as high as 30 times 12 would be 360 plus 50 would be $410. And so you could say that a reasonable range might be values that look like that. I would, again, kind of like with the earlier problem with the graph, like if your assumption was this, that's logical and I would accept it. If you made an assumption about some upper limit, excuse me, as long as it was logical, I would have accepted it. And then finally for our 100 level question. Now, first I have to apologize to my 1A students because the version of this quiz that you got had a typo that ended up creating something that was impossible to do, because originally it told you that the graph had to decrease on the entire interval from 1 to 5, but you have to have a range between -4 and +4. That becomes pretty much impossible to do with all of these other conditions. So we corrected that starting with my 2A class to change it now to decreasing on the interval from 1 to 3. So for my 1A students, if you at least met most of these conditions in a way that was reasonable, then I'll be giving you credit. Everybody else that has the edited version should be able to construct a graph that meets all these requirements. So the first thing we note is that the domain, and the other typo that we fixed after first period is that those are just going to be or equal to inequalities. So we're going to hit everything on the x-axis, -5 to +5. Excuse me, there I go again. And then we're going to hit everything on the range, -4 to +4. So I'm just going to make myself some little tick marks here just to kind of show the bounds of my graph. Like it should go all the way left to right and should hit values as high up to here and as low down to here. Now, the function has to increase on the interval from -5 to -2. So from here, -5, -4, -3, -2, we need to be increasing on that interval. You'll also notice right here that we're told that for an input of -3, the function should give an output of -2. And that's going to fall in that interval. If the input is -3, the output is -2. So that point has to be on the graph. We also know that when we get an input of 0, we have an output of 1. So my graph has to pass through that point. And when we have an input of 2, we have an output of -2. So my graph has to pass through that point. From -2 to +1, the function has to be constant. And then from 1 to 3, the function has to decrease. So here's a thought of how we might go about that. So we need an increasing interval from here to here that passes through that point. But as soon as we get here, we need a constant interval that's going to have to be a flat line, and it needs to hit that point. So we know that this portion of the graph has got to be a flat line right there that passes through 1 on the y-axis, because it's got to be a constant interval, but it's got to contain that point. So we know that portion of the graph is going to have to look like that. Now for the left-hand side, we just need to be increasing. We want to go from a low end of -4 at the far end of -5 up to that. Now, you're going to have a hard time getting that with a straight line, but we don't have to be straight lines. It's perfectly fine to be curvy. So, oh, that was bad. Let's redo that because that was almost vertical there at the end. There we go. That could work. So that gives us increasing, passing through that point, constant, passing through that point. Then we need to be decreasing and hit that point. So we have met this. So far we have met this requirement, this requirement, this requirement, and we have touched all 3 of those points. Now I just need to make sure that my range gets as high as +4. So I'm going to put myself a point right here, and in the second half of my function, just draw a portion of the graph. Let's do that a little better. Draw a portion of the graph to connect those two. So something like that. That would be something that then has a domain, -5 to +5, check. A range of -4 to +4, check. Increasing from -5 up to -2, constant from -2 to 1, decreasing from 1 to 3, and then we have touched all 3 of the necessary points. So that graph should meet all of our requirements. Now, of course, is every graph have to look like that? Not necessarily, but they're probably going to look pretty similar in order to meet all the requirements. And so there you have it. There is the work through of our 6 questions for the first topic 1.5 checkpoint. I hope that seeing my work through of these problems is helpful for you as you're reflecting on the work that you've done, and hopefully using that as an opportunity to grow your understanding. And if you feel like you are ready, come back and reattempt to show a growth in your mastery. As always, thanks for taking the time to watch, and I'll see you later.